Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Today is day 28, hardware design of three-phase induction motor using Arduino microcontroller. I welcome you everyone here. Yes, I welcome all the participants. Am I audible? Can you please confirm? Am I audible? Am I audible? Can you please confirm? Yes. I am just waiting for a reply. Can you please confirm? Am I audible? Can you able to see my screen and my voice? Can you able to hear my voice? I'm just waiting for a reply. Am I audible? Am I audible? Can you please confirm? Yes. Thank you, participants. Thanks for your valuable reply. Thank you, Vedant. Thank you, Bino. Thank you, Ajit. Very good evening. Warm welcome to this session. So today we are going to discuss about the hardware design, how we can design our own hardware for the induction motor. So let us check one by one. So before start the class, yes. About the Pantech is a educational equipments manufacturing company. From Pantech, you will get a lab equipments for EEE, computers and site-related products. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 10 lakh students. And attendance form will be provided at 7:30 p.m. So please don't rush up about the attendance form. So definitely you will get attendance form. And then use the coupon code to join in the internship portal. And last date 5th March. So I have I am going to discuss about how to design the hardware program and how to download the code from the from the computer and how to verify the output. So step by step we will give you, and already I run the output and then I took a video output in my laboratory. I will show you one by one. So part by part you can get exploration. And if you have any questions, you can ask me. I will try to give you the answers. And if you have any questions about the previous class, also you can ask me, so that I will give you, and then and after that we can move ahead. Yes. And so if you, for speed control of induction motor, so this is the block diagram. This is the block diagram. And so this block diagram is a common block diagram for any power electronic application. So this will suitable for our applications also. So input is going to be connected to the power circuit. So this power circuit will have a controller. So controller generally it will be a microcontroller. So in this case we are going to use a Arduino microcontroller, and the load is going to be as a inverter. Induction motor. So what is the exact power circuit of the for the induction motor control? Can you tell me what is the exact power circuit for speed control of induction motor? Can you tell me? I'm just waiting for your reply. So what will be the power circuit for speed control of induction motor? What will be the power circuit for the speed control of induction motor? Can you please comment? I'm just waiting for your reply. I'm just waiting for your reply. Can you please comment? What will be the power circuit? So exact power circuit. Is it rectifier or DC to DC converter or inverter? So which circuit or which topology will be the suitable for speed control of induction motor? Can you please comment in the comment box? I'm just waiting for your reply. I'm just waiting for your reply. I'm just waiting for your reply. Can you please comment? Can you please comment in the comment box? I'm just waiting for your reply. Yes. So what will be the proper power circuit for speed control of induction motor? DC to three-phase AC VFD. Generally we can call it as a inverter model. Generally we can call it as a inverter model. Right? So generally we can call it as a inverter model. Right? Can you able to understand what is the inverter? Yes. No, not a rectifier. It's a inverter. So not a rectifier, it's a inverter model, right? If you have any questions about it, please comment. Yes, thank you participants. Not a converter or rectifier, it's a inverter model. So now we are going to discuss what is the induction motor. So induction motor working principle generally will work with a mutual induction principle. It works under the mutual induction principle. So this motor has a two type of motor. One is called the slip ring motor and another one is a squirrel cage type of motor. Right, squirrel cage type of motor. And the working principle, we will apply a three-phase supply into the stator. So the rotating flux may create on the stator side, right? So that rotating flux will intersect the rotor bar. So since the rotor bar is a free end, so the rotor bar will receive a force to rotate from its standstill position. So now the rotating flux, the rotor also will receive a rotating flux. So due to this, the force may create on the rotor side. So due to this principle, the rotor will rotate. But the rotor speed and then stator rotating flux speed will not be equal, because the stator rotating speed will be a synchronous speed and the rotor speed will be asynchronous speed. So that's why we are calling as asynchronous speed, asynchronous motor, right? Still, difference between inverter, rectifier and converter. Oh my god, it's very too late question. The inverter is used to convert DC to AC, rectifier is used to convert AC to DC, then converter or chopper is going to be used to convert DC to regulated DC. So this is the working principle, right? So this is the working principle. Just a second. Yes, right? And so if you take this one, see here the green color denotes that it represents the rotating flux on the stator. Rotating flux on the stator. So the violet color denotes that rotating flux on the rotor. So this rotating flux on the rotor will create a force on the rotor side. So if you take this animations, see the rotor will tied with stator rotating flux. So, but it will try to catch the stator rotating flux, which it won't happen, but it will keep on rotate. So if you stop the input supply, then the rotor will get stopped. Right. So this is a very basic principle of the induction motor. So again, if you take a type single phase or three phase, under the single phase there are split phase or capacitor start and then capacitor start run induction motors, right? Similarly, for the three phase induction motors, squirrel cage and then in slip ring induction motor, for every motors, for the three phase motors, for any type of the three phase motor, so this working principle and this procedure is the hardware speed control method. Right, just to follow this one. For the single phase, again the methodology is same, but instead of three phase topology, we have to use a single phase topology. So this is the detailed block diagram of the induction motor. So this is the detailed block diagram of the induction motor. So in this detailed block diagram, see here first you should identify the what is the motor rating. Very first one, the motor rating. So here we took a three phase induction motor in squirrel cage type, right? So first we have finalized three phase induction motor and then squirrel cage type, and the available power supply. So next part is the available power supply. So since this is going to be a prototype, so we have developed for the available power supply is the 230 voltage input. 230 voltage AC input. 230 voltage AC input. Okay, and the rotor motor is a three phase induction motor squirrel cage. Three phase induction motor squirrel cage. So now we have to introduce one by one the block diagram. So since it's a 230 voltage AC, right? See, we need a DC power supply, because here we have to apply a variable voltage and then variable frequency. So both the parameters should vary. So by this is called as fixed power supply 230 voltage AC. and straight away we cannot use this voltage. We cannot use this 230 voltage AC to implement the speed control. So we have to apply a power converter in between these stages, right? So here in the practical case, I reduce the voltage rating in some level, But if you need exact 230 voltage and single phase, or 230 voltage 1 HP and 440 voltage, you can do whatever whatever you want, you can do. But I have used some scale down, because actually if you are, since you people are academic people, so no need to invest much level. So no need to invest, and then no need to go for the exact level, since you are going to be you are going to prepare a prototype model. So you can use this small scale down rating to finish your prototype project, right? So now I choose two different type, and I will tell you one by one. So how to select the components, and then how to fix the voltage range and all. So try to engage with the entire class. So very first we take a power transformer. So this may be an isolation transformer or scale down transformer. Suppose if you are, why we have to use the isolation transformer in the sense, suppose if you are going to measure the any waveform, waveform of any across any components, then the input supply and then CRO, that is a display devices, ground should not connect each other. So here, if you use power transformer or isolation transformer, then we can avoid that short circuit usages. So after the power transformer, so we have to use the bridge rectifier. So it's a rectifier, uncontrolled rectifier, and so this bridge rectifier will have a four diodes, and along with the filter capacitor. So now you may get a DC power supply at this point. So this we can call it as a DC bus voltage. So this voltage will apply to the three-phase inverter, and this inverter needs a controller, right? So here we took a Arduino controller as a PWM controller. So this controller is going to control the inverter output voltage. Is it clear? And the driver circuit is the isolator between the power circuit and microcontroller circuit, and this is the power supply for the driver circuit, and again this is the power supply for the microcontroller. So do you have any questions about the block diagram? If you have a questions, you please comment. Do you have any questions about the power controller block diagram? If you have any questions, you please comment. I will try to give you the answer. Right. Very good evening, participants. Yes, thank you, Abdul. So now I am going to select. Ratings. So the very first one is 230 voltage single phase main supply. 230 voltage single phase main supply. So the option 1 and then option 2. So the blue color denotes that option 1, and then black color denotes that option 2. If you use the isolation transformer 230 voltage and then 6 ampere, so since it's a single phase, three phase 1 HP motor, so no need for the higher ampere. So 6 ampere is enough. So it's called isolation transformer. So you will get a voltage across after the bridge rectifier will be a 325 voltage DC. 325 voltage DC. So if you use 230 voltage isolation transformer, right? And after the three-phase inverter, you will get a 220 voltage per phase voltage. Then by changing the PWM, then you can get a controlled output voltage. Similarly, you have an additional. You can reduce somehow voltage less than that 230 voltage. So from you have to use this transformer as a 230 by 110 voltage. So 110 voltage. So in that case, you will get a 155 voltage will be the DC bus voltage, and the AC voltage will be 110 voltage. Per phase voltage will be 110. Right. So for this range also you can ensure that speed control logic will work. And option 3 also you can use. Again, still the 50 and 50 voltage also you can keep. So the secondary will be the same 230, and then secondary will be the 50 voltage. Secondary will be the 50 voltage, and output voltage will be the 50 hertz, 50 voltage AC. But the speed will be will not be a rated speed. Somehow it will be less speed only, because you are going to apply only 50% or 100, 70% of the voltage only. So in that case, you can use reduced step level, right? So do you have any questions about the rating? If you have any questions, you please comment here. Is there any converter for single AC to three-phase AC directly? You have to design your own converter. You have to design your own converter. If you have any questions, you please comment here. I will try to give you the answers. Is it clear how to design, how to select the power transformer? Is it clear how to select the power transformer? If you have any questions, you please comment. If you have any questions, so please comment. If you have any questions, you please comment. I will try to give you the answers. Yes, sir, all three-phase motors are 415 voltage, so it's a line-to-line voltage will be the 415 voltage. The per phase, like a VAN will be the 230. VAB will be the 440. VAB will be the 440. VAN will be the 230. VAN will be the 230. Is it clear? If you clear, so please comment in the comment box, super clear. If you clear, so please comment in the comment box, super clear. If you clear, please comment in the comment box, super clear. Yes, I am just waiting for your reply. Thank you, participants. Let's move next one. And so see here the power supply. Yes, thank you, participants. So here the input we are going to apply, and this is the step down transformer, isolation transformer. Based on these options, you can choose whatever you want. You can choose option 1 or option 2 or option 3. For all these things, for this range, the motor will rotate at the rated speed. So for this range, it will be 50% less than the rated speed, and for this rating, 70% will be the less than the rated speed. Yes. So now the bridge rectifier. So here we will apply a 230 voltage. Here you will get a rated voltages, and so this is the bridge rectifier configuration. So this filter is going to give us a DC rectified and smooth DC bus voltage. So generally you can keep 1000 microfarad, 1000 microfarad, and based on the voltage range. So it will be electrolytic capacitor. And if you are applying a 230 voltage, so here you have to use 400 voltage DC bus voltage, 400 voltage DC. Or if you are keeping single capacitor, you can use a 200 voltage with the two capacitor. Then you can go ahead. Or else, you can use a single capacitor as a 400 voltage DC electrolytic capacitor. If you are increasing the capacitor voltage range, again you have to invest a lot. So for a 1000 microfarad 400 voltage capacitor costs you about 600 to 700 rupees. Similarly, if you take a 1000 microfarad and then 200 voltage, so the cost you about 100 to 150 rupees. So you can use two capacitor to reach the voltage level. Right? And so this is the after the rectifier. So we are going to connect as a inverter model. So now you should understand the working principle of the inverter. So now you should understand the working principle of the inverter. So generally we can run this inverter. Suppose if we are not using the sine PWM, then there are two general methods. One is called 120 degree mode and then 180 degree mode. Right. So for understanding the purpose, like the voltage variable frequency drive, to implement a variable frequency drive, so you must understand the working principle of 180 degree mode or 120 degree mode. So to understand the working principle, you just keep in your mind that switches namings. So to switches the naming, right? So here the switches nothing but, so this is the S1 and then S2, S3, S4, S5 and then S6. So this is the typical switch identification level of 3-phase induction motor. So level of 3-phase induction motor. Right. Ganesh Kathmande, I attended 25 days sessions but no certificate. You will not get a certificate because the series should get end. Then only you will get a certificate. How to connect two capacitors? Use just parallel connections. Just use the parallel connections. So you can download the content from the internship portal. So now let us understand the working principle. Yes, so 180-degree mode and then 120-degree mode, whatever it may be, the working principle are same. So to understand this one, why we are naming this one in the sense. So this is the A phase, B phase, C phase. If you take any instant, some voltages will be the positive and then some voltages will be the negative, right? Some voltages will be the negative. So in that case, because each and every voltage is phase shifted 120-degree each other. So now we have to understand the concepts. Take the inverter working principle. See in this colors, the dark color denotes the positive waveform and then light color denotes the negative waveform. Dark color denotes the positive and the light color denotes the negative, right? So now if you take this period, so we can call it as a mode 1. So during this mode 1, so there is no any changes. See, A is completely dark and then B is completely light, which means that negative and then positive, and this is also positive, right? See here, if you take this block diagram, if you take this graph, see here, if you take this graph, see this is the mode 1 period. So the B phase is negative and the A phase is positive and then C phase also positive, right? A phase positive, B phase negative and then C phase positive. Similarly, if you draw the other graph, so you will get accordingly. So now you have to achieve the inverter output voltage at this moment, at this point. So you have to achieve this voltage as at this moment. So how you will achieve this similar kind of voltage? So now if you take a frequency 50 Hertz, you take a frequency 50 Hertz. So in this 50 Hertz, if you take a frequency as a 50 Hertz, right? And the total time period will be, what is the total time period of 50 Hertz? What is the total time period for the 50 Hertz? Can you comment? What is the total time period for the 50 Hertz? Can you comment? Can you comment? What is the total time period for the 50 Hertz? So we are going to get 20 milliseconds. So now you have to divide into 20 milliseconds into 6 modes because we are running for the 6 modes. So approximately each and every mode will have a 3.33 milliseconds. 20 milliseconds. So 3.33 milliseconds the time period for the mode, each mode. So now you can convert the switching states. See during the mode 1, if you operate the Q1 and Q6, so this is for 120-degree mode. This is for the 120-degree mode. Okay. So here if you operate Q1 and then Q6, then you will get a proper output voltage to achieve that proper one. Similarly for the mode 2 and then mode 3, mode 4. So this is switching pattern. So now you have to generate the entire pulse as a PWM with Arduino microcontroller. So by generating the PWM using the Arduino microcontroller, so you have to use this logic. I will tell you one by one. So now the component selections. So here you will get 220 voltage, 100 voltage AC. This is the input transformer, and this is the full bridge rectifier, and then capacitor will be like 1000 microfarad, and then you can use 200 voltage capacitor. And these these MOSFETs as a these switches as a MOSFET, I use 250 IRF P250. 6 MOSFETs I have used. And the operating frequency maximum you can use the switching 25 kilohertz. And the PTP connectors we have to connect. So this the two pins are this is the PTP and this is also the PTP connector, right? So now the boards this is the inverter board, and here we have to apply a input AC input, and this is the single phase full bridge rectifier, and 1000 microfarad 200 voltage capacitor, and 6 MOSFETs. 6 MOSFETs, and then output terminal. So here we may take a 3-phase output. 3-phase output, and this black color denotes that MOSFET along with the heatsink. MOSFET along with the heatsink, right? So this is the components identification. And now we are going to use the driver model. So here we use the 6 individual driver model. So from the microcontroller we have to connect the input to here. From the microcontroller we have to connect the input to here, and after that this is the power supply. So straight away you can connect, and TLP250 optical isolator, and this is the totem pole amplifier model, and then driver power supply, right? And Arduino microcontroller, we just took a basic Arduino microcontroller board, and this board you may take because actually here GPIO models about 15 pins will be there, so you can use any one of the pin. Any 6 PWM we need, so you can take any GPIO as a 6 PWM output, and the 2 input we have to take. So the motor will rotate from 10 Hz to 90 Hz. So if you are reducing the frequency less than 10 Hz, the motor will not rotate. Again, still if you are increasing the motor above 90 Hz, and the motor will increase the noise. So the better operating range will be 10 to 90 Hz. By default, the motor will rotate at 50 Hz as a rated speed. Right? Is it clear? Is it clear? Can we get lag or lead by using capacitor 120 degree each? No, that's not a right way, because the capacitor will always phase shift only 90 degree. Is it clear? If you have any questions, you please comment here. And from the microcontroller, we are going to take PWM1 for the switch number 1, and then pin number 4. So like that we have to assign each and every pins. Like that we have to assign each and every pin. Right? If you have any questions, you please comment. Try to give you the answer. I will. You can download all the code from the Pantech website. So this is the typical code. I will share you. Please wait. Yes. And so this is the pin assignments. And after that, this is the flow chart. First we have to initial all the port, and then assigns the pin PWM. Initialize the assign the pin outs for the proper inputs, and initialize the lookup table. So here we have to refer the charts. So the charts nothing but this this switching states we have to generate it. So this we have to convert as a lookup table. So this flow chart or this switching states needs to be converted as a lookup table. I will tell you and how to convert the lookup table and all. So please try to engage with the entire class. And after that, visualize the lookup table, and here the main function will be called, and is under the main function. So the PWM out will generate. So if you reset the pin, again the main function will get run. And again, if you reset the pin, then the program will get end. Yes. See here, this is the just simple PWM. So here initialize the pulse PWM. So this is a PWM 1 and then 2 up to 6 PWM we can take. So this is the pin numbers, and see here we are assigning by default it's as a pulse output, and see here we are taking the pulse 1 high, and for the next pulse 2, pulse 3, pulse 4 are 4 low, then except pulse 6. So just to take this chart, flow chart. Yeah, see here we compare, just a second. Yeah, so this is the mode 1. So this is the mode 1. So in the mode 1, pulse 1 is the high, and then other pulses are low, and last pulse is high, sixth pulse is high. So now we have to wait for a moment. So just call this function. So just we created as a subroutine. So like that we have to create it. So now we can go for two cycles. So just generate a lookup table for the two cycles. Pulse 1, mode 1, mode 2, mode 3, mode 4, and so the six functions as a first cycle, and then the seventh subroutine as a mode 1 again. So like that if you rotate, then you may get a 12 modes. Now you have to call the first subroutine and wait for the moment. So this moment will be a yes. So this moment is going to be a delay time. Suppose if you take a if you assign that value as a 10 hertz, then automatically the time will get calculated. Now you can rotate from 0 to maximum. Now you can, this is the delay time. So the maximum delay time you can operate it. So once the loop over, then it will be continuously, it will be a 1. So it will be continuously, it will get rotated. So like that we can pass the value, and we can achieve we can generate a PWM. Right? Is it clear? If you have any questions, you please comment. I will try to give you the answers. If you have any questions, you please comment. I will try to give you the answers. Attendance form I have to participate. Thanks for. So if you have any questions, you please comment here. What is the heat sink? Can you please explain? Heat sink is it's a protection device to dissipate the heat. To dissipate the heat. While you operate the MOSFET, so due to the high current spike as well as the voltage spike, the internal temperature of the MOSFET will get increased. So we have to dissipate the heat by using the heat sink. By using the heat sink. If you have any questions, you please comment. I will try to give it. So now I will show you the hardware demo. I will go. Just a second. Give me a second. I will open the file. Yes. See, for example, so here we have modeled all the hardware. So this is the yes, this is the Arduino model, and this is the driver model, and then MOSFETs along with the input and filter capacitor. This is the motor. So now we have downloaded the code to the Arduino microcontroller. So from the Arduino microcontroller, we can get pulses like this. We can get a pulses like this. You have to, if you download the code, then you may get 6 different PWM pulses. So that PWM pulse we have to connect to the driver model. So each and every driver model will carry the output pulse. So this PWM pulse is connected to the MOSFET. See here, if you connect, you have to ensure that. So the PWM output of the output of the Arduino will be this level. So like a 5 voltage. If you take a driver output, will be 12 voltage. So initially it was the 5 voltage, now it is the 12 voltage, right? And first you have to ensure that one, and once if you apply it, then the motor will try to rotate. Here we have connected the input power supply. So here we have yes. So now the motor started to rotate. So now if you just to change the time delay in the program, then you can increase the speed, you can vary the speed. So now this is going to be as a driver input, so drive cycle. I will show you the tomorrow in the hardware demo. So how we can change that speed by assigning the dashboards input, right? So this is the simple hardware demo. You can implement it, and in the internship portal you can download all the schematics and the project files right away. If you download it, then this is the hardware inverter output pulse. So this is the hardware inverter output pulse. This is the hardware inverter output pulse. So since it's a 120 degree, so 120 degree mode, so you will get a single step only. So this is a high voltage and then 0 voltage, again negative I voltage. Like that we can generate a hardware outputs. If you have any questions, you please comment. I will try to give you the answers. For further research, you can implement IoT model and then speed display unit and then protections, cooling systems, everything you can implement here. Mr. Karthik Raja, please comment. Please share your WhatsApp number, email ID to this number in WhatsApp. So you can download all the PWM code and then plus circuits from the internship portal, right? Chat, and in all your email, my WhatsApp number is there, so you can take and then you can ask your question. So thank you. I will meet you in the next class. So tomorrow in email as well as the WhatsApp, I will share you the demo video of the EV. Thank you, participants. Thanks for your valuable time, and we will meet you in the tomorrow class.